Assalamualaikum warahmatullahi wabarakatuh. Good day, ladies and gentlemen. Thank you for attention to this presentation. I will presentation in this paper about manufacturing assistive technology on the SS1-V1 Weapon Stock to support shooting stability for DEPOHAR 1510. The other military unit have different main tasks. Di Pemelihara 50 TNI AU, the task is repairing and maintaining the heavy level alutsista radar TNI Angkatan Udara. Soldiers in DEPOHAR 15 are not only required to be proficient in carrying out repair of radar spare parts, so they can operate for 24 hours. The limited ammunition support of the Mabes TNI AU shooting training activities are not carried out at any time, only done once in one semester. The limited number of training for DEPOHAR 15 soldiers caused the average score of 15 soldiers to shoot at 28%. The explosion on fire from the SS1 weapon produced a shock force toward that year. The external force acting after the explosion is known as the recoil effect. The recoil effect on the SS1-V1 weapon produced a strong impact on the shoulder, which caused the stability of the weapon grips to change. Setiawan et al. State the weapon sway, shock strength, and body sway had a close relationship with firing of a weapon. Monument et al. Explained that the recoil effect results in change in the stability of weapon position and body balance when holding the weapon. The sway of weapon affects the position of the shoulder, which contribute to the stability of the weapon when held and reduce the performance of the shoot. Impact force on the shoulders resulting from the recoil of the weapon must be damped by external pressure through a mechanism in a way that can spare and divert the load from the vulnerable anatomical location. The anatomical particular joint send soft issue the piezoelectric is material properties reduce loading rates. Three physical factors in the recoil effect contribute to the shooter during firing the weapon include recoil impulse, recoil speed, and recoil energy. The design of recoil pad on the SS1-V1 weapon stock is expected that the stability of weapon during an explosion can be achieved. This study aims to determine the extent of the application of assistive technology as a recoil pad on the SS1-V1 weapon stock to reduce the backward shock generated during shooting, thereby increasing stability when shooting. This study used a quantitative method approach that is focused on collecting and analyzing numerical data to find pattern and means. The recoil pad produced using material consists of rubber, silicone rubber, polyethylene, foam, polybonding. The application recoil pad on SS1 weapon stock is additional component produced in weapon stock. The use of the force sensitive resistor sensor FSRS type RC C18.3 ST has a measuring range of 20 gram to 6 kilonewton. This is designed with Arduino Uno Atmega 2560-based microcontroller system with 10-bit analog to digital converter capabilities. The design of this system is measure the amount of pressure that occur during the explosion and is connected via cable installed in recoil pad on the SS1 weapon stock. The placement on lead 3-meter diameter with a red light is placed on the end of gun barrel to see the impact of the explosion. An Arduino board will use to read the analog signal issued by the FSRS in a voltage divider configuration, where the force applied to the FSRS can be estimated via the sensor calibrate curve. Application of SRS sensing with emphasis of using calibration curve from the manufacturer with calibration check. Participant involved is many as 5 soldiers by shooting in standing position. Measure for each soldier on 3 shoot each on target 100 meter away with firing time 3 minutes. The maximum rise of the weapon barrel of the vertical direction observed from the far video is about 5 cm. The placement of the FSRS attack on the recoil pad consists of I1 is the FSRS is placed on the top of stock, I2 in the middle of the stock, and I3 in the bottom of the stock. The test of the impacts on the bullet on the firing range value from 10 in the middle to 1 outermost in age. This test is measure the average value, the impact of shooting range. The physical characteristic of recoil pads with absorbing rubber and silicon rubber manufacturing by Pachmeyer, United States of America. A recoil pad with absorbing rubber is made of soil rubber with ventilation that combines shock absorption, good memory, vibration isolation, and vibration damping characteristic. A recoil pad with silicon soil rubber design with unique shock absorb to reduce fatigue and impact. A recoil pad made by polyethylene from polybending products by PT Rijen Jaya Mulia in Indonesia. A recoil pad with the polyethylene from polybending material makes a soft foam pad for comfort, lightweight, and has a soft foam pad that protects the user from slipping, sliding, or bouncing. From figure 1, so the measure recoil the soldier shoot without the use of recoil pad with an average value of 5.5 kN close. The maximum force sensitive resistor is 6 kN. Figure B and D show a soft and rubber pad with ventilated and polyethylene foam. Polybonding use the protective recoil effect can reduce the magnitude of impact force by 22.5% and 33.0%. Although this value is peak horizontal force look approximately the same as the peak force, figure C show that impact force can be damped by silicon rubber by 64.4, twice that on the other two material. Peak power is much less in the case that is in previous test. In interesting that the duration of the shoot was significantly shorter, about 6 until 7 milliseconds. This test result showed that horizontal force peaks at about 1.8 kN and speed of about 8 meters per second after the signal on the sensor from the initial firing starts to rise after firing, and about 7 meters per second after the shot change level in the barrel. These results are not much different even though the use of silicon rubber material gives an indication of more stability in shooting of a soldier. A positive effect on the study identification of rocket pad and weapons on other content is possible for assisting of rate of it and making decision to fire. That that rocket pads and assistive technology is made by rubber polymer foam, silicon, rubber, and other soft material. Help protect and rocket the weapon. The silicon rubber rocket pad is better than two pads and is able to reduce kick the shoulder tail. The use of recoil pad on the shock of weapon during practice help in shooting accuracy and precision. These are my reference. Thank you for your listening. May all those we have shared be beneficial for all of us. Wassalamualaikum warahmatullahi wabarakatuh.